Hey guys, this video is really long, so I have a cute intro. I'm going to save it for one of the later videos that's not quite so long. Let's get straight to notes. In this first video of domain and range, we're going to go back to the very first lesson we did in the course and talk about functions and what would have to be true about a domain and range in order for a relationship between two things to be considered a function. So first of all, the learning target for this lesson is that we can identify the domain and range of a function. Remember that your vocabulary can be found in your glossary at the back of your packet if you need it. The relationship between two quantities can be shown by a set of ordered pairs called a relation. In the first lesson, we talked about the fact that a function was a special relation in which each input has exactly one output. Most of the relations that we are going to work with this year do end up being functions. But what we're going to talk about right now is how do I know for sure? I can't just assume because there are relations that aren't functions. So there's a couple different ways we're going to talk about. First is to scan the domain. What I mean by that is look through all your possible x values. Domain, you may remember from middle school, is all the x values of a set of ordered pairs. So look through the domain. If there are any x values that repeat, you don't have a function. Okay, so if x repeats and those two x's or three x's or however many have different y values, then you don't have a function. So what I mean by that is, let's say you have these ordered pairs. 1, 5, and I don't know, 2, 7. Those x values, the domain would be 2 and 1, and then there's another 2, but it's already there. So those x values repeat, and they have different outputs. This would not be a function. If that was a 3, then it would still be a function. Another way that you can determine whether a function is with the vertical line test. If any vertical line, meaning up and down line, passes through more than one point of the graph, then the relationship is not, or the relation is not a function. So what I mean by that is if I go through and I draw a million little lines, vertical lines, all through here, nowhere does it cross in more than one spot. Okay, it always hits at one spot on that graph. So that means this is a function. Same thing here. It doesn't matter where, it doesn't matter where I draw my line, it's going to be a function. It's going to hit in just one spot. Whereas something like this, you can see from this line right here that it does hit in more than one spot. If you think about the ordered pairs, if we just made up values here, if this is x is 3, this y is 2, and also, how many did I do? 1, 2, 3, and also 6. So we've got 3, 2, and we've got 3, 6. That means that domain, that single x value, has two different y outputs. So that's why if you have a graph, you can use a vertical line test. Notice that if I draw a vertical line over here, it only hits once. But if it fails the vertical line test anywhere, it is not a function. All right, so let's look at the different ways we express relations. The first way is just through ordered pairs. If you have a list of ordered pairs, that's a relation. Sometimes, too, we will display them on an XY table. You guys have definitely seen this before. Here, the x's would be 2, and then I've got a y of 3, so there's that ordered pair. I've got 4 as an x and y as a 7, and I've got 6 and 8. That's one way to display this relation. On a graph, I would use my ordered pair to go over 2 and up 3. I'd go over 4, 1, 2, 3, 4, and up 7. So okay, and then the last one would be over 6 and up 8. Notice the vertical line test here would pass because when I draw vertical lines through those 3 points, never does the vertical line cross more than one of those ordered pairs. The third way, which you may not have seen before, is with mapping. In mapping, your first little circle, or sometimes it's a rectangle if we're being weird, is going to be your X or your domain. And the second one is going to be your Y or your range. So what that would look like is you'd have a 2, a 4, and a 6, because those are your X values. And then you'd have a 3, a 7, and an 8, because those are your Y values. And then the thing that makes a mapping unique is it shows the action of going, if you plug in a 2, you get out a 3. And you'll have an arrow telling you what to do. So typically we put these in order, and then we put these in order from least to greatest. So sometimes those arrows might cross, like if 2 had gone to 8, then you would see an arrow going over here. Okay, so the domain of a relation, I've already said, is the set of inputs or your X values of your ordered pairs. So what X values are used in the graph? Another way you could say is how far left and how far right does it go? Meaning if you have, well, I'll show you an example in just a minute. The range of a relation is the set of outputs or your Y values of an ordered pair. What Y values were used in the graph? Another way to say that is what's the vertical movement? How far down does it go? How far up does it go? All right, so let's do some examples. In this example, the domain, we are simply going to list out the X values. So the domain then is -1, because I've got a -1. I've got a 2, I have a 0, and I have a -7. You will sometimes see these listed in least to greatest. So especially if you're doing multiple choice or something, you're probably going to be looking for this as your domain rather than this. Okay? Same thing with your range. Your range is all your possible Y values. So remember, in an ordered pair, you have X and then Y. So I'm going to pull 4, 6, 4, and 1. If I put those in order, I've got 1. I have a 4. I've got 2 4s. Don't list that twice. Once it's in the range, it's there. You're done. All right, now, is this a function? To determine if it's a function, remember, we look at our domain and see if there are any repeating values. So -1 only shows up once, 2 only shows up once, 0 only shows up once, and -7 only shows up once. So this is a function. It doesn't matter that the Y's repeat. The X values do not, therefore it is a function. All right, the domain here. I would need all the X values. You can take the time to write out the ordered pairs for these, but I wouldn't. I would just go through and say, all right, I have one that has an X value of -4. I'm looking at the X axis. I've got a -4, and then I've got a -3, because that ordered pair's got an X value of -3. I have a 0, because the X value here is 0, even though the Y is 1. I have a +3, and I have a +5. All right, for the range, I'm going to do the same exercise, except I'm looking at my Y values. The range of these, I'm just going to start at the bottom and work my way up because I like to have it from least to greatest. So the lowest possible Y value I see is right here at -2. There are 2 of them, but again, I don't have to list that twice. I just list it the one time. The next Y value I see is 1. So I list that, and then I've got one here with a Y value of 3, and one with a Y value of 4. Again, I had some repeating offenders on my range, but the X value, I can draw a vertical line through each of these ordered pairs. Let me go ahead and do that for you. And it does not cross a second point. Okay, that just crosses the 1 point. The y-axis just crosses the 1 point. This one just crosses the 1 point, and this one does. So because never does a vertical line touch more than 1 point, this is a function. All right, so, you know, this comes up often in math where we have several different words that mean the same thing. So this little hint is very helpful. When I say X values, that's the same thing as saying domain. That's the same thing as saying input. That's what you're plugging into an equation or to a function. That's also your independent variable if you're thinking in science terms. Your dependent variable relies on what you put in for your x value. So it's your y value, it's your range, it's also your output, because what you plugged in for your independent variable resulted in this output. You can also sometimes see it written as f of x, as we've discussed before. All right, so let's go ahead and do example 3. In example 3, we have a mapping. Again, this is a rectangle just because those are easier to draw when I make the notes. So the domain and range, remember that the first circle or oval or rectangle of a mapping are your x values or your domain. So all you have to do for the domain then is list out 2, 3, 4, and 5, because those are my x values. Your range are listed right here. My range is -3, -2, 5, 7, and 9. Now, is this a function? Remember, in order to be a function, you can't have any repeats of your x values. It's okay to have repeats of y's. It's not okay to have repeats of x's. Well, let's think about this 2. This 2 only goes to -2. So if I were to write that as an ordered pair, it would be 2, -2. This 3, though, has 2 arrows coming out of it. So the ordered pairs there are 3, -3 and 3, 5, because it's got 2 arrows. So that means I have a repeat of x values. That means this is not a function. If I were to plot those 2 points, a vertical line would go through both of those points. All right, one more example. Students who take the AP government exam can score a 1, 2, 3, 4, or 5. Last year, 2 students scored a 1. Nobody scored a 2, 3 students scored a 3, 7 students scored a 4, and 7 students scored a 5. Write these scores as a set of ordered pairs and plot them on the coordinate plane. All right, so we were told 2 students scored a 1. So if x is the number of students, then 2 students scored a 1. That's my first piece of information. No students scored a 2, so 0 scored a 2. So I'm going over none, but up 2. 3 students scored a 3. So I'm going over 3 and up 3. 7 students scored a 4. So 7 are going up to 4. And 7 students scored a 5. So I'm going over 7 and up to 5. So my domain then is going to be 0, 2, 3, and 7. My range is 1, 2, 3, 4, 5, all those possible scores. And is this a function? Well, I had 2 different groups of kids that were 7. So this vertical line here means that this is not a function. This is an interesting question. Should we connect these points with a line? Remember, connecting points with a line implies that you could put in fractions. You could say 0.1 and see what that value is, and 0.2 and so on. So in this case, it doesn't really make sense to connect it with a line, because your x values are how many students. We don't have 0.1 students taking this test. Students are only whole numbers, so you can only have an input of 0, of 1, of 2, of 3, of 4, of 5. It's got to be counting numbers because we're talking about actual people. So fractions and decimals don't make sense. So no, because people are whole numbers. All right, you guys try a couple. I apologize for the long video. I know this was a lot of information, but go ahead and go to the U-Tries and let us know if you have any questions. Don't forget to check your answers, and I'll see you in the next video.